I am Kathy Tafel, and I do lead Meetup's mobile engineering group. The last time I gave this talk, I was at a conference and I asked, so how many of you have been to a meetup? And so that's kind of not a really good question to ask tonight. So I thought I'd turn it around a little bit to how many of you have helped out at a meetup? Yeah, and how many are meetup organizers? Yeah, so we really appreciate everybody who comes to a meetup, who helps host a meetup, and who helps organize a meetup. And we do want the world to self-organize around community. And so we try to structure our business also in a little bit of self-organizing. So I'm going to talk a little bit about how we do things at Meetup, just not really so that you can copy us, because I don't think that anybody any business should be doing its own thing. But you can see, like, if you get to the place where we are, we're about 180 people, about 80 to 85 of them are engineers, and we work on really small teams. So as we scale and as we get bigger, we wonder, how do we communicate with each other? How do we add technology? How do we do this with the absolute least amount of process, but not so much less process that we can't get things done. So let me show you what we're going to talk about for the next 30 minutes or so. Here we go. I'm going to talk about how we define success at Meetup and how we measure our progress. I'm going to go over some design goals and let's see here, as well as talk about how we, I'm going to use a case study of how we built a variant service, a split test framework. So I'll show you how we set it up and how we get the results. And I will get this pattern down with these like 6 machines here. Let's see. I'm going to talk about the infrastructure, and then I'll talk about the future. So first, let me just tell you a little bit about Meetup, and I'm going to talk a little bit about Meetup because, you know, it's not just a navel gaze. It's to give you a sense of again what do we think of as success. So if we're having a split test, what does success look like when we have a good test? So in 2002, we asked this question: what if we use the internet to get off the internet? And then a few years later, in 2009, we launched our iOS app as a result of a hackathon, and changed it to this question: what if we used our phones to get off our phones? So again, about success, we're really proud of having a business model where we don't need to sell advertising, but we want to talk a little bit about success as being more than being profitable. So we view success as when a person shows up to Meetup and gets to do something they love, like this. And we think that's the thing that's really going to make a difference in this world, to the individual, to the Meetup group, and ultimately to the whole world. And it doesn't have to be that serious. It can be something like this, where we're talking about code. It could be a yoga meetup. It could be a breast cancer support meetup. It could be heavy. So what are we really after? So the Human Brew Computer Club was founded 42 years ago in Menlo Park. And the founders were interested, like Meetup organizers are today, in maintaining a regular open forum for people to meet up in person to work on making computers more accessible. So Steve Wozniak went to a meeting and says in his book, after my first homebrew meeting, I started designing the computer that would be later known as the Apple II. It was that inspiring. So we call that a happy show up. That's success to us. That was a very happy show up that caused the Apple I into existence. So that's really hard to measure, as you might imagine. And not every meetup is going to engender an Apple I. But so we have a proxy for that, and we call that our North Star that we're shooting for of RSVPs. So if you say you're going to go to a meetup, that's what we can measure. And that's success to us. So let's just keep that in the back of your head. So over those 15 years, we've tried to get a lot of people to that perfect meetup. And if you have been at a tech company for a long time, you know that if you have done anything for 15 years, you will have a lot of product and tech debt. But I guess I want to talk about that 15 years. So we're at scale because we've gotten successful. And so what does that mean? Scale means we have hundreds of millions of unique visitors every year and millions of every active users every month. And you know, we can talk about what success looks like in scale. So we're 180 people, and that is bigger than many companies, and it's not a startup anymore. It also means we have hundreds of thousands of groups scheduling hundreds of thousands of meetups, events every month, and we send billions of emails and push notifications to remind people to get to events like tonight. And if you think about scale in physics terms, inertia or momentum, it takes a lot to shift anything at scale and propel it in a new direction. So with 15 years of product life cycle and scale, we got that. We had a lot of technical debt, and I'm not going to talk too much about this, but I will point this out if you're looking at tackling technical debt at scale. My CTO gave a really great talk about this. And from the mobile perspective, to tackle this on iOS, we went all in on Swift. We wrote our app last year in Swift and our Android app with material design, and we just recently switched to Kotlin. And our other engineering disciplines have also been at it. We're going to ship a React Redux NPM rewrite to our website the beginning of November, and it's in preview right now. We have all of our monolith database is getting moved into microservices and Kubernetes containers, cloud. We've upgraded our data pipeline to be viewable by Looker with an AWS Redshift. We're using end-to-end tests. We're using Robot. We've got CI/CD on GitHub. You know, when I joined Meetup last year, it took a couple days to deploy new backend code to production, and today it's about 2 hours. So we shipped maybe 1 or 2 releases a day, and now it's about 8. And that's a ton of work, and that's just been in the last year and a half. And it's been all rainbows and unicorns. I mentioned these other disciplines not only because they're part of this story later, but because even if we might, as iOS and Android folk, want to stay siloed, we do better work when we understand the larger system in which we operate. But my talk today isn't about tackling technical debt, it's about iterating. And I'm not going to suggest that we're done tackling it, but we're significantly complete, which means we get to talk about adding new features, which is really fun, greenfield kind of stuff. So we shipped our app last September. And of course, the next question was, what's next? And the most obvious thing that was lacking to me was split testing. How do we know what we can do? How do we know we've done a good job when we add a new feature? But our members told us that the most obvious thing that they wanted was a calendar feature. So we added that. And a split test framework isn't something that I can just add by myself through sheer force of will of having my team make it. I needed the whole company to buy in. And again, we're self-organizing. I have to go out and influence others to get there. So the next opportunity for planning, I pressed for an AP framework. How many of you have used a split test framework? A little smattering of you. So I'm going to call out some of the positives and negatives of using a split test framework. Our product teams have big ideas, and we might want to try a big feature and make sure that we're not causing the business harm. Or a test can point out when we have really had a great success and will have a measurable impact on our results. And remember that success is all about RSVPs. So we did have a split test. Let's see. Where am I? I'm so sorry about this. So I'm going to show you an example of why we might want to test something. So here's a nice meetup that happened last month in New York here. Well, what if I haven't been to IO Soho before, and gosh, 185 people are going and I don't know any of them. It sounds kind of daunting. What if we want to try something that makes the list more interesting? So maybe I'm in 8 groups with a host, and I share another 4 with that Harrison guy. Maybe I've been to another meetup with them, and I'll say yes to this meetup because they RSVP'd. But we don't know if it's going to work or not, so we want to run an experiment. This is the sort of thing that would have been painful to test in the back end. And it would introduce dependencies into the presentation layer where dependencies shouldn't exist. And it's a test we couldn't have done. We had a split test framework that ran in the back end, but we couldn't do anything on the front end. It didn't talk to it. So we made arguments to get something that would work for us mobile folk on the engineering roadmap. So what did we want to build? We had this backend framework. We want to make sure that we can test the framework. We want to make sure that it can at least give us some measurable results, and it has to work for all of our consumers. We have a website, an iOS app, an Android app. We want to test front-end user experiences. We have a recommendations engine, and our machine learning scientists want to learn data models and see which ones wins. We have new microservices, all those things coming online. And we want to run experiments on new platforms 2 years from now that we don't have any idea what they are. So it builds on success. Anything that we have, we want it to build into our RSVP engine. We're already measuring RSVPs. We measure these successes on every platform, and it should go into our data pipeline. And it should show the winners pretty simply. It starts where we are. Anything has to work on our current systems or at scale, or it's just a non-starter. Many off-the-shelf solutions would work great if we were starting from scratch, but can't plug into these into where our business logic is that easily at scale. And we've iterated away from some older systems to reduce our tech debt. Any new solution should work in our current design patterns, or it will take longer and cost more. And it's separable. So when you have a winner, you want to be able to easily cut the code out. Reminding product to make time for this is a lot easier. The easier it is to delete the code. Or maybe we didn't think of everything at the start and we want to change our minds. We shouldn't have trundles of thought in various bits of the code base that we have to go track down when updating a part. Clear separations of concern make this easy. And we want it to be cost effective. So this is something where we were thinking about, we really want to have this this test. Why can't we just use Mixpanel or something like that? And one of the problems at scale is that some of the business models are such that if it's by event or monthly active user, we're already at a place where it costs us less to hire somebody to build something than to pay somebody like Mixpanel. Or if we go down this road and go with a third-party solution, and all of a sudden we don't want to run experiments because we think it's going to be too costly. And then the sooner we have something in production, the better, and we can adjust our requirements. So what's the minimum need to ship? So these are the kinds of things that are in the back of my head when I'm looking at the solutions that my team are proposing and are working with other parts of the company. So these were what we wanted to build. And we decided to go with our own rather than going with a third party because of all of these considerations. And that's something that you have at scale. If you were a startup, maybe you'd go with something like Mixpanel or some of these other experiment engines, and it would just work out fine. But when you're at scale, you can't just add things in willy-nilly. So we introduced a lightweight split framework that we call the Meetup AB infrastructure, or maybe. Yeah, I like the logo. So let me show you how it works using the original example and its code. A great benefit of scale is that I get to just show off the work of my team. And so I'm going to show you some Swift work. We also have it working in Android using RX Java and some observables and all that lovely stuff. But I'm just going to go with the iOS code. So let's go back to this Meetup event and the list of people who have RSVP'd. So here's how we build out the UX. It's a table view section, pretty easy. And we want to test the hypothesis that this view might be more successful, where success is measured by people saying they'll show up to a meetup. We're checking to see here if we get a section back from our experiment. And if we don't, we'll default to the original creation method. And then, so what does it look like to build the experiment slice? I hope you can read this. If you can't, I have the slides up and I will make sure that everybody knows where the slides are. So don't feel too bad if you can't see it. And feel free to copy our concepts. So we only want this code to execute if we're in the variant rather than the control. And once we guard for that, it's just a matter of building out the UX. And that's as it should be. We're going to have this little extra code to clean up after the fact. So here, if this variant one, we'll just delete the first 2 lines of the function and that's it. Now, to be fair, one of those lines is hiding something a little bit more complex. We have an enum defined on a MABI manager that will conforms to being experimenty. We hide the strings from our regular code. So that our enum is all we need to match up our Swifty bets with our server-side code. And can we see the results? What does the results look like? So what you see on this dashboard is a third-party service called Looker. And Looker is a tool that gives us insight into our tracked data. Anyone at Meetup can visualize data stored in Redshift. Like I said, we're a very egalitarian company, so anybody with our Google single sign-on can go into Looker, and it's a really neat tool. We have our objectives and key results up there, and anybody can drill down into any of the graphs and explore and come up with questions. And we've had even some people on our community team drill down and ask some questions that have turned into products. So it's a really great tool. So this Looker dashboard is set up so the p-value is colored red until it's below 0.05. I'm told that p-value is very important, and if I were a statistician, I would I could tell you why it's important, but you know, that's the great thing about being in my little silo is that I don't have to know what that means. I could just trust that another part of the team has built this dashboard correctly. But anyway, I'm guessing we're going to end this experiment before too long because it's not providing a lift. And we've reached statistical significance. When you're experimenting, you can move fast. It's okay not to win every time. So I'm showing you some things that have failed because it's okay to fail and try things. And so if we go back to our physics metaphor, it's really hard to change the inertia of a system at scale. So maybe we learned that experimenting with this part of Meetup isn't going to get us very many results. So we've actually learned something from our experiment. But what's in common with our Swift app? Yeah, it's that string. As soon as our tracking system detects a new experiment in the wild, Looker will display the experiment name in a menu list. And I can see the results of any experiment. That's pretty cool. Our product teams can define an experiment, test a new user flow, and see the results on a dashboard the next day, provided we've shipped it up to the app or Play stores. So that I think that's kind of magic. Like we didn't do anything on the Looker dashboard to make it show up. It just shows up because we're reporting that in our own tracking. And we didn't have to do anything. That was a system we already had in place. So that's one of the things that I love is using things that we've already done to make new things. It's really kind of magic. And I love this one, right? But no, it's kind of not magic. We're really just passing around strings. And that's a rightful reaction if you bought into how evil selector-based coding is in Objective-C. And I know that in Swift 4, there's some really nice things with key paths. And in case you hadn't noticed, one of the problems with string-based keys is that you can pass typos around really easily. And that missing L is kind of killing me, and it's been killing me ever since I put it in this presentation. But I'm told, my engineer tells me that the product manager put it in Jira that way, and he just copy and pasted it all over, and it went live. And as soon as it went live, we can't correct it. So that's maybe in action. And it's not quite magic, but it works and let our people get experimenting pretty quickly. And we were able to get this a proof of concept into the wild in about 7 or 8 weeks from our first architecture to having a result in the wild. And I think that's pretty impressive when you're operating at scale. So let me talk about some of the connecting tissue. How do we get from Swift to Looker? So I'm going to go back into case study mode. Again, I don't want you to copy any of necessarily what we did, but I want to give you an example to both show a little bit of humbleness and how big companies can actually operate for better or for worse. So how do we really make engineering decisions in an organization of 80? It's not quite so big that it has like an intense amount of structure. And it's not quite so small that you can just go and stare at the person next to you until they come to your point of view. Our data platform team is the one who really took on the architecture of this. And they used the mobile platform team as a guinea pig. And I actually sit as product owner of the mobile platform team as director. But we don't actually sit on the same floor. We're not on the same team. And so we had a meeting, occasionally Meetup people, we have meetings. And so the principal engineer and the data scientist, they met with us, and my chief Android person, Mike Kesselman, and iOS, Paul Bruneau, and it's 5 of us from pretty different disciplines. And we go kind of deep and occasionally broad. So they being the clean back-end kind of people they were, they showed us this pristine diagram of their thoughts with proper boxes separating all the concerns. And the rest of the company uses Google Docs. So brace yourself for some white slides. So we have like our people, we have like our front ends, we have some nice things in the middle there. But all we really need to do for our proof of concept is make sure that we've got somebody consuming an API that picks something out of a variant control engine and tracks conversions. We don't need to do this other fancy stuff that we think we need, and we don't need to have it out for every user. So that's how we're able to get to a minimum viable product. And so then one of the data scientists goes in, starts talking about the code, and even showed this slide exactly. And Mike and Paul had some really good input on there. And they invited us because we were there to negotiate the API. And they start talking about how to call the service. And we're like, wait a minute, we don't call services directly. We're mobile engineers. We thought we were there to talk about the API. And they were talking about the API of their own service. And so we go back and forth like this. And finally, Mike steps in to clear everything up. They think they're over in their variant control box, and we think we're over in our place. And finally, each other is thinking of the API differently. And really what we learned is that we as mobile engineers need to start calling the API an edge server. that's just kind of a fun way of looking at some communication problems that can happen when you're talking to other disciplines. Before you get too frustrated, make sure you're talking about the same thing. So we had just a slight problem. We don't have any engineers on my mobile platform team who write edge server code. The variant service people thought that they had their API defined and they had resourced to build out the API. And but we want to get the project into production as soon as possible. How could we possibly get the information from the backend into our current, with our current mechanisms without breaking our API syntax too much? Maybe without even making another network call, because we're mobile engineers and that's how we like to roll. So we netted out using one of our old school internet hacks. Does anybody here use Alamo Fire? Is anybody here an iOS developer? Okay. Well, anyway, that's great. Alamo Fire is this wonderful networking stack. It's very abstract. Does anybody here write HTTP headers? Okay, we're getting close. We're getting closer. So at any rate, how about JSON? Does anybody know what JSON is? Okay. So good. So most of the time, mobile engineers live in JSON, and they know how to serialize and deserialize JSON. And most mobile engineers don't have to worry about HTTP headers. It's just abstracted out by everything. But we have old school internet hackers. We're a 15-year-old internet company. So we have a lot of custom code in our HTTP headers. So we thought we'd use that. More strings. So we're going to use our HTTP headers, and I'm going to show you a little bit of code like this. And so now you're going to see some Swift. So I thought that this would be kind of fun for everybody. But this is actually kind of neat to know that you can actually use internet protocols on iOS that look just like other internet protocols. So here's something that everybody might use. The thing that's special to us starts with an X. And so we make our own request serializer to add these fields. Using the enums makes this pretty clean. And a lot of these fields just get logged by our edge server for the most part, like an Apache log, right? And they go through our data pipeline for analysis. But some of them do set server behavior. And occasionally that behavior, let me see, hold on a second, sorry. Occasionally that behavior causes a header to be returned in the URL response. So we have a parser that checks for any special responses. For instance, we only trigger an App Store rating request if our server flag is set on. To extend this, we defined with our backend folks an X Meetup variants header, which on a request asks for experiments of interest. So we don't need machine learning or notifications experiments, for instance. We only want the ones that are for our own tests. So in order to encode that header, we take a dictionary of experiments and generate a header string. We don't always add that header field, but when we do, oops, the server will return another string, and decoding the response looks like this. And I was told by my lead engineer that they don't like adding header strings, but if you do find yourself in the situation, there's some nice conveniences on the components separated by. So it's pretty simple on our part. And I want to point out that we are building here on decades-old work from the Internet Engineering Task Force. And the neat thing about conforming to standards and protocols is that a fancy new language like Swift, with great SDKs like Alamo Fire, can adopt those standards and protocols. And if our backend also conforms to those standards and protocols, it's actually pretty easy to extend current functionality to do something using strings. So I thought I'd talk a little bit more about the variant service itself, which is also kind of a stupid service. which we kind of like. We don't really need to be clever everywhere. And if we can be as stupid as possible, then it probably will work the first time. So I want to look at our experiment string here. We saw it in the Swift code and saw it in Looker. So how does it get there? For the moment, our variant service is a microservice written in Scala, living its own GitHub repository. And I should point out, from the mobile perspective, we don't really care about the implementation details as long as we get the results from the header string. So Meetup could decide, and it might very well decide, in fact, I think we're going to experiment in the next quarter with replacing the variant service with something else. But that's awesome, because we were able to get to an implementation with a really stupid service, and I won't even notice on the front end if we replace it. But it's really easy to contribute to this service. 28 contributors to this GitHub repository. Remember, we're an engineering organization of about 80 people. Now, to be fair, they've added about 1 line of code. So I don't know how many people ran their own tests in our old way. We had this old split test framework, but I can tell you the no mobile engineer went into our old monolith code and ran an experiment on the front end. And at least half of my team have opened up a PR in this repository. They can find that 1 line of code, easily, because we made microservices that have their own GitHub repository. And they don't even need to set up or learn a dev environment, because they can go right into GitHub and change that 1 line of code themselves and open up a PR. Merging those repos pushes live within the hour. Again, remember, our backend monolith took hours to build. And this is live in an hour. It's pretty awesome. And the variant service itself was brought up quickly because our core engineering team made this really wonderful code gen tool that makes a Kubernetes image. So this fits our design goals. We've scaled up the number of people who know how to use the variant service. We've used the design patterns, the variant service itself, built out by our core platform team. So the first magic is HTTP headers. The second magic is mobile engineers writing Scala code. And the third bit of magic I alluded to already. So we added tracking to get our data into Looker, and so our strategists could make better decisions. So even without split testing, our successes get logged by our edge server and sent through our data pipeline for analysis. So if you remember, we have this North Star metric of our SVPs. And this is what Meetup's heartbeat looks like. I'm cheating a little bit by not giving you the X and Y axes. But that's okay. So what you can see is that we taper off a little bit at Thanksgiving and Christmas. And then when everybody makes New Year's resolutions to do better, then we shoot right back up again. So you'll also see it's kind of a self-fulfilling prophecy. We also send out marketing to get people to go and make New Year's resolutions. So who knows whether it's a chicken or the egg, but it doesn't matter because it's making good results in the world. So hopefully, you know, as we get better and more international, this line will just keep going up instead of having these EKG lines. So we mostly already had the conversion side working. That red box, if you remember the architecture, we already had the conversion side. And so maybe we weren't processing it when we start sending up these new things. But we already have the mechanisms in place. So we just need to switch on a variant on a UX, but change nothing else of the app's behavior. We log whatever views or RSVPs people are making as normal. And it's the data side of things that reports whether there's a winner or not in Looker. This is a bit different than you have some other systems with SDKs that have to go report up to their own dashboards, and you have to go figure it out. So any code we don't have to write or maintain is magic. Oh, I'm sorry. That's a year over. So that's one Christmas and another Christmas. Yeah, and I promise this one is bigger than this one. Lies, damn lies, and statistics. So the last little bit is what we call the MABI manager, and I've got one for Android, but I want to wrap these things up. So I'm just going to show you Swift code. And so this manager lets our app not care about how those A/B slices get to the decision point. It manages making the HTTP requests and parsing the response of those special headers. It defines a protocol, and it caches the variants so we don't have to request them every time. So let's go back to our example. We defined an enum used to request a slice for the front-end UX, and it conforms to our experimenting protocol. These enums are then used by the MABI manager to request experiment info from the server, and we vend that slice to the UX in our app. And that's our lovely protocol-oriented programming. We love protocols. So the first iteration was really lightweight. And I apologize, can you read that? Yeah, you can kind of read that, but I'll have slides up online. So the first iteration was really lightweight, just 70 lines of code for the basic MABI manager class. And I'll just point out that we keep our variants cached in the user defaults dictionary. And I'll detour to say that he didn't write pristine code the first time, you know, but I also want to point out, like, one of the things that you could do at scale is you have PRs, and then that helps get you some unity of thought. And it is nice to go back in time and make sure that future programmer knows what's up. So we pull the code out that we want the rest of the app to call in one extension. And so I'm just showing you a little bit of Swift thought patterns here. So if you're not, didn't think that anybody's a Swift, so I'm just going to go really fast over this. But only 4 things the rest of the app needs to know about: to set up, to request a header with the current experiments, to store the result of the request, and to request a slice from the UX. Moving on, let's see. And the private implementation details for those APIs happen in another extension. So we get to have some really clean separations of concerns. And this is one of the things that we really love about Swift and protocol-oriented programming. And it kind of lets us do the same kind of lying to the compiler that we did in Objective-C and loved so much. And so this is just internal maintenance that nothing in the rest of the app should care about or know about. And it's all called from an app delegate. And that's all we needed for the first iteration of our system, which was live in production in March. So our first experiment was just switching out a button title to see if it made a difference in our RSVPs. It really didn't, but it was a string that powered the test, and strings make it really easy to set up and see the output immediately. And since then, we've run at least a dozen tests and more, since we obviously didn't get everything right on the first try. We learned that we might want to force a variant during testing for our QA people, so we can do that now. And we learned that we maybe only want to enroll people in a test if they're in Australia, so we can do that now. And we don't have as slick an admin panel as off-the-shelf solutions. It'd be nice if our product people could define an experiment name and the weights for the slices somewhere besides Jira. We might want to declare a winner. And we brought this, we made this, even though this whole talk is about being at scale, we built it as a proof of concept and then just started using it for everything. And now today it's bursting at the seams, and that's why we're looking at a third-party variant service. But again, it's building into the design principles that we had when we started at the beginning of the year. We knew this might happen. You know, maybe it's a better fit for a serverless solution than our Scala. But it's better than our 1.0, and let me tell you why. It works for our apps, and it should work hopefully for whatever platform comes down the line in the future. It builds on our success using all of the architecture and systems that we had. You know, a generic system may not be the thing that you want when you're hacking away at your core business. So that's one of the things that we're choosing really, like what do we really care about? We care about success. The success is happy show-ups. And we're only able to make this work because of our definition of success. And I hope for the human race's sake that if you want to have some sort of testing on your own, you have as lofty a goal as this, because you might have to do some more work if that's not the case. This starts as where we are. It uses our current design patterns. So many of our team are now not finding themselves hesitating to experiment, which is another thing that can happen at scale. You don't want to mess the business up. You don't want to experiment because you're afraid it'll screw something up. And now 28 people just dug in and made something go. It's separable. We abstracted away the variant service. So if we need to replace it, we can. It's cost effective. No one team is working full time on this anymore. But as we devise new features, we can prioritize them, and it's been pretty easy. It's also lightweight. And we were able to get the first version out, like I said, because we didn't try to do too much. And we've made product decisions as a result of experimenting, and mostly, like I said, we're not stopping ourselves. So maybe we're on the right track. We're asking questions that we couldn't ask 6 months ago, and we've really only scratched the surface of what's possible. So far, we've acted, it maybe has been more of a guardrail than a true petri dish, in that we're mostly just watching to make sure we don't cause negative impacts to the business. But now that we have a few guardrails in place, I expected the change, and you'll see lots of new app features in the new year. Some of them will work, and some of them won't, and that's okay, because iterating at scale means if we can just take one small piece and experiment, it's okay to get into production and fail or win. I'm okay with us winning too. If we want a new feature, we can decide it on our own timeline and make it available much more quickly than if we're waiting on a third party and we're iterating in our old, or when we were iterating in our old backend monolith. And we'll make mistakes, and I deliberately showed you some of our mistakes because I think that's the ones that you can learn from. And nothing is perfect the first time. So I hope you've enjoyed this journey through Swift, even if you are not Swifty people. Some Scala, some IETF protocols, and some data analysis. And I hope you'll find that if you go down the manager's path, it's a huge win when you can keep everyone trying new things without fear of failure, especially at scale.